right?
Yes.
So that is so machine learning is all about that game, incorporating all the domain knowledge possible in the model. If you are able to do it, then your estimation error will be low. But if you make wrong assumptions, your approximation error will be high. So if you want both to be low, you should not make assumptions which are not true in practice, and you should not leave any assumption not made, which is true in practice. Both. Is this clear?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
That's the message of. So in essence, this is what happens in general also, not only in supervised learning, but in many machine learning problems. This is what happens. If you are able to incorporate all the domain knowledge available, expert knowledge in the model, then that's the right model, right? There's no other right model. But unfortunately, many times what will happen is you may not have any access to such domain knowledge. For example, if you are working in Microsoft, right, and then you are a machine learning scientist, you are given the job of understanding some concept hidden in some data, but data acquired by Microsoft will have lots of constraints on privacy. So what Microsoft will do is anonymize everything. It won't even tell you what's the domain of the data. You are simply supposed to write a machine learning algorithm and submit it to a black box environment, and the environment automatically runs it on the data and churns out the answers. So it's a completely black box environment. Right? And this is what actually happens in Microsoft. Almost. I mean, I'm approximating what happens to a reasonable level enough for us. So what will happen if you do such kind of a, try to do machine learning in such kind of a framework where you have no idea what is, there's no domain knowledge, right? Forget about domain knowledge. You're not even allowed to see the data once, even the machine learning, scientist, right? So it doesn't know the dimensionality of the input or how many factors are there. Is it a real valued output or nothing he knows. He has to solve, you know. So in such a scenario, what will happen? Your approximation error, your approximation error, perhaps, you can imagine a situation where, you don't assume anything, then your model is very big, but then what will happen? Your estimation error will suffer. And that's not good. Right? Yeah. So this is so for various reasons, we may have, this modeling maybe is a difficult problem. I tried to mention a few. Okay, so let's perhaps stop here because it is already 5:30. I'll open the floor for discussion. So any questions based on our discussion, whatever knowledge you already have on machine learning, or some comments, or some relations you want me to make with other stuff,
Actually, so far whatever is discussed regarding this supervised learning, could you recommend me any book where I can find this information for more reading?
Right. So
Is
I
it
will
is
do
it the
that.
same?
Yeah. So that's the same book, but the problem with the book is the book is very detailed. Now, if I just ask you to read this from a book, you will not be able to parse the book. Okay. Now, that doesn't mean you will completely leave the book. What I'll do is, using my lectures, and I'll also circulate summary notes with exact references. I'll tell, this is the definition. Definitions I'll highlight in blue color. I'll write theorem statements if necessary. I'll write, I'll cite references. I'll say page number, this in this textbook or this paper. Like that, I'll give a summary notes based on. Okay.
Okay,
Now,
sir.
using both of them, you should be able to parse, navigate through the textbooks. Without that summary notes, if you just read textbook end to end, you will not be able to understand. It is very difficult. It's very dense. Okay. You don't need to understand all the contents also for this basic course. Now, why not pick the other alternative is, why not pick a very basic book? The very basic books won't give you the right intuition, according to me, right? So if you take a general book on machine learning, they may oversimplify things and give you a wrong notion of, or a highly simplistic notion. I mean, I'm not saying
Yeah.
the wrong notion,
Yeah.
a very highly simplistic notion, which perhaps it is not justified at this 5000 level course at IIT. Right?
Yeah.
So,
Sir, I have a question. Sir,
Okay,
yeah,
sir. Yeah. Thank you.
is it
yeah.
possible, are there any techniques that would let us, let a machine learning scientist approximate the domain constraints or something like based on the data alone?
See, that's a nice question, but as I told you, then that would mean everything can be got from the data, in which case the entire basis for learning is not there, right? So it's the same paradox which we'll read again, that given enough data, you should be able to solve any problem. That is not correct. The bias is very important. You will have to have a bias to, you know, force learning through. This is the philosophical answer. Okay. And even this philosophical answer is backed up by formal theorems. There are many no free lunch theorems, so-called no free lunch theorems, which say that just based on data. See, this is the idea. I'm telling it in informal way. Just based on data, you will not be able to solve the problem. You will need to give some bias. It may be a very simple assumption, but you will have to make. If you don't make, there's no, no way you will be able to solve the problem. Okay, like in this case, for example, in case of empirical risk minimization, if you don't put a restriction on function class, there is no way you can proceed, right? There's no way if you want to follow this framework. I'm saying, right? So bias is very important. That's what the formal results as well as philosophy says. Now there are other kinds of impossibility results also which are known. For example, many of these, now the question can be that let's make some modeling assumptions along the lines you have made, but can't we verify those modeling assumptions based on data? Then we are done, right? Then everything is based on data. Perhaps that's the question you are asking.
No, but so I know, so let us say I have a model and it doesn't fit well even in the training set. Then then that means I do not know the domain constraints properly, right? So I would want to make better constraints.
Right, right.
And so if it is possible for me to find out, okay, what kind of those constraints can be, maybe then we can model that. That's
Right.
the kind of question.
Correct. So, that's the kind of question. So there are many paradigms. So you are asking about how do you go about doing modeling? Okay. So we will study some examples of models, right? So starting from very simple models like linear models to some complicated models in online learning and so on and so forth. Okay. But so we'll be also studying about some deep learning models and so on and so forth, right? So you will be exposed to some various ways of thinking about models. Okay, just changing the functions from linear to non-linear is not the only game. There are many other games which people play to do modeling, right? And some of them we will learn in this course. For example, neural networks play the game in a different way. SVMs or kernel methods play the game in a different way. By game, I mean, how do you model, right? This is the question you are asking, right? So this game of, going about figuring out the model is played differently by different algorithms. For example, there is an entire big way of, modeling using probabilistic modeling. That's what is done in graphical model courses or graphical models in general. These are called as probabilistic graphical models, right? So, in a sense, uh, in simple words, I would say there are three very powerful, different thought processes, entirely different thought processes for generating models. That means for coming up with models. One is based on deep learning. Another is based on this kernel methods and large margin methods. Another is based on probabilistic graphical models. Now, each of these have their own advantages and disadvantages. As of today, maybe results are more favorable in when deep learning models are employed, but that was not the case even few years back, and we are not sure what will be the case down the line, right? And knowing various models is also helpful, because in one modeling we can perhaps bring in aspects from another way of modeling, right? So the way we will answer your question is, we learn these different kinds of models, and that's what perhaps will help you to understand how modeling is done in general. So the answer is yes, we will do some of these things.
Okay.
These are the three main things we'll cover. Probabilistic model, that's one way of thinking, which is completely different from what we have done now. And what we have done now is, and what happens in deep learning is also a bit different. I mean, they won't differ at this point, but kernel methods and deep learning models differ once you start talking about non-linear, functions. And the way they model nonlinear functions is very different, and that's what gives them their advantages as well as disadvantages. So what I have mentioned now is a general set of guidelines to choose a good model, right? So you should incorporate all background knowledge. That's the general guideline. But as you're saying, in a practical machine learning example, how do you go about doing modeling? Is you should understand the existing models, how they have incorporated domain knowledge, and that's what will make you understand in a new situation how you should do modeling. And as I said, it's a skill, it's a very difficult thing to. Yeah, any other question? Okay, so if that's it, let's call it a day, and I'll share some notes, summary notes, as I promised. Please go through them and utilize the time you have to.
Sir, the OneNote would be available to us, right?
That is already shared with you, but somehow last time the notes is missing. I don't know why.
Exactly.
So this time I have written it, I think, in a personal note. I'll share you the link.
Okay, sure. Thank you.
Yeah.
Thank you, sir.
Yeah, thanks.
Thank you, sir. Bye.
Thank you, sir.
Bye.
Thank you, sir.
Thank you, sir. Thank you, sir. Bye.
Bye.
Thank you, sir.